Okay, here's number 15 from section 2.4. And what we want to do is determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why not. Okay, so since the slope of the curve, I kind of gave you a little information here, since the slope of a curve, y equals f of x at a point, is a limit, that limit exists if the two-sided limit of the difference quotient exists. That is, if the limit as x approaches a from the positive direction equals the limit as x approaches a from the negative direction equals some L, for some real number L. So we need to check both one-sided limits. So this was our function. The problem is we have a piecewise function. So we've got a function here and a function here. 2 minus 2x minus x squared, x is less than 0, 2x plus 2, x is greater than 0. So it's a piecewise function. And what we want to do is we want to check this, and the indicated point was at x equals 0. So this is my limit formula, all right? Or my formula for my slope, which is a limit. You see, m equals the limit as h approaches 0 of f of a plus h minus f of a all over h. So this is a limit. So we have to check that, and then basically this is when a limit exists. Now in this case, it's not going to be x approaches a, it's going to be h. But this is basically the general idea of a left limit and a right limit. Okay, so it looks like this in the book, but now basically we're going to change the x to be an h. So we have to check both the limits. We have to check the left limit and the right limit to make sure that this does exist. Otherwise, we won't have a slope. And note that f of 0, now this is tricky about these piecewise functions, so kind of watch this because this will crop up again. Notice that f of 0, this is the 0, this is when it's equal to 0, is 2x plus 2. All right, so again, we've got to check the left and the right-hand limits. So this is back from the book. Okay, so we're going to check both one-sided limits. So this is the left-hand limit. Okay. Now if we look at the left-hand limit, this is going to be h as, this is the limit as h approaches 0 from the negative direction of f of a plus h minus f of a over h. Okay. And then I'm going to substitute because my a is going to be 0 from up here. So that's going to be f of 0 plus h minus f of 0 all over h. Now remember, since h is approaching 0 from the left, it's going to be a negative. So I'm going to be adding a negative number to a. A is 0. So that means that this is going to be less than 0. All right, so I'm going to be using this part of the function, all right, for a plus h here. So that's going to be this function, 2 minus 2x minus x squared. So now it's going to be 2. Now remember, what's 0 plus h? 0 plus h is just h, so that's going to be easy to substitute in. So I'm going to put this h into this function because I'm in the negative realm, so I'm using this less than 0. Again, because I'm adding a negative number to, because this is approaching, h is approaching 0 from the left, so that's the left of the number line, so that would be a negative, so I'm adding some kind of negative to 0, so I'm going to have a negative number. So I'll be over here. All right, so we put this in, 2 minus 2 minus 2 times h minus h squared, minus. Now, this is 0. What's f of 0? Well, this is equal to 0, so I have to use this function. Doesn't really matter because it's equal to 0. I'm not adding any h to it, so it's going to be 0, so I'm going to use this function. So this is the tricky part. So x equals 0, so I'm going to use 2x plus 2. And I'll put the 0 in there. So keep that in mind. So we're using one function when it's less than 0, another function when it's equal to 0. Okay, that's the tricky part. So make sure you take a look at that, think about that. That's the hard part. Or tricky, I should say. It's not hard, it's just tricky. Now once you have that, then we can just simplify our limits. We know how to do that. So that's going to be 2 minus 2h minus h squared. 2 times 0 is 0, so I've got 2, negative 2. The 2's cancel. If I substitute, I get 0 over 0 because I still have an h in the denominator, so I can factor out the h. I can cancel that. I have this limit. And then when I substitute h for 0 in this limit, I get negative 2. So that's my left-hand limit. Okay? Now we have to find the right-hand limit. So again, when we follow this idea, remember this is, I could have written h, because it's whatever is approaching. Okay? So we're going to take the right-hand limit. All right, so this is over here. So try to follow this. So this is going to be the limit as h approaches 0 from the right of f of a plus h minus f of a all over h. And again, my A was going to be 0, so I put 0 in here. So the limit as h approaches 0 from the positive direction of 0 plus h minus f of 0 over h. Now, since h is to the right of 0, I'm approaching 0 from the right, I should say. So I'm approaching 0 from the right, it's going to be a positive number, so I'm adding a positive number, all right, to 0. So it's going to be greater than 0, whatever. This will be greater than 0. So I'm going to use this part of the function, because that's when x is greater than or equal to 0. So I'm going to use this 2x plus 2. So that's why I have 2h plus 2. Because remember, what's 0 plus h? That's just h, so that's real easy. So I just substitute h in here, so it's going to be 2h plus 2. And then as we did in the last part, again, x is equal to 0, f of 0. So that's no problem. I'm using this function here, this one here, because that's the equal. Sorry, you can see that. Okay, so that's when x is equal to 0, greater than or equal to 0. So since it's greater than or equal to 0, we use that function for both parts of the right-hand limit. And then we just simplify it out. And this simplifies even easier. This is 2h plus 2. And again, this is just negative 2. And the 2's cancel, so I've got 2h over h. I can replace the h over h by 1, so I got the limit as h approaches 0 of 2, and that's just 2. Now notice that my left-hand limit was negative 2, and my right-hand limit was 2. So since the right-hand limit 2 does not equal the left-hand limit negative 2, and the slope does not exist at x equals 0. So there's no tangent at x equals 0 because we can't have a slope there. Okay, I hope that makes sense. That's pretty complicated, but try to look through it to make sure you thoroughly understand this and go over and over. Now, if you do have questions on this, I can go over this one in class because this is a tricky one.